Friends, today we are going to learn the characteristics of periods and the groups in the in the modern periodic table. So now let's start with the characteristics of periods. Point number 1. The valence electrons or outermost electrons. On moving from left to right in a period, the number of valence electrons in elements increases from 1 to 8, though in the first period it increases from 1 to 2. Alright, now I'm going to explain how this happens, but before that let's make a note, shall we? Sure. Yes, now I'll teach you how this happens. Okay guys, now let's start. Now we can see this strip of period. This is actually the Okay guys, now these are the elements of the third period. As you can see here. Now the first element is sodium, second is magnesium, third is aluminium, silicon, phosphorus, sulfur, chlorine and argon. Here you can see the atomic number written. Here this is the atomic number. So sodium's atomic number is 11, magnesium's atomic number is 12. Now as I told you, so now let's see the electronic configurations. The electronic configuration of sodium is 281. Okay, now can you see this highlighted thing? Yes, just see this properly. Magnesium's electronic configuration is 282. Again 2, here 3, 4, 5, 6, 7, 8. So it keeps increasing. You can just see here number of, wait, I'll just show you properly. Yeah, number of valence electron 1, 2, 3, 4, 5, 6, 7, 8. So this is exactly what I'm speaking about. So let me revise again. The first characteristics of periods. On moving from left to right in a period, the number of valence electrons of elements increases from 1 to 8. But make a note, in the first period it only increases from 1 to 2. Alright? Now let us learn the second characteristic. Okay guys, the second characteristic is valency. Alright? On moving from left to right in each short period, the valency of elements increases from 1 to 4 and then decreases to 0. Now let's see how this happens. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. Okay, now sodium's valency is 1, magnesium's valency is 2, aluminium's valency is 3, silicon's valency is 4. Mind it, it forms a covalent bond. Phosphorus, again, as I told you before, now it starts increasing. Sorry, in this set till here it increases, then from here it's 3, 2, 1 and 0. So you can see that from here till here it decreases. So this is what I was talking about. The valency for in a period first increases till 4, then decreases to 0. 0 means, so 0 means the valency is 0. Therefore, the element having valency 0 is of course a noble gas. Here argon is the noble gas. Now let's go to the third characteristic. The third characteristic is size of an atom. Size of atoms or atomic size, as its common term is. Okay, now on moving from left to right, let's take this example again, shall we? On moving from left to right here, here, the in a period of the periodic table, the size of atoms decreases. Mind it, from moving from left to right, the size of the atoms decreases. Now I'll be telling why. When electrons increase in an atom, all right, now we can easily see that valence electrons in the outermost orbit keeps on increasing, or we could just say that the atomic number keeps on increasing in a period from left to right. Hence electrons and protons increase. Now when these keep increasing, the attraction between the electrons and protons also increases. Hence the electrons are pulled a little closer to the protons as we go from here till here. Hence in a period, the largest, or you could say the atom which in a period, the atom which has the largest size is the first element, and the atom which has the smallest size is the noble gas, or you could say the last element. All right, now let us go to the fourth characteristic. The metallic character. On moving from left to right in a period, the metallic character of elements decreases, but the non-metallic character increases. All right, I'll tell you why. We know that metals usually give out electrons and not accept them. Now till 4, every element over here, till 4, we have just learned over here, right, this the valency increases till 4 and decreases till 0. Hence till 4 the valency keeps on increasing, or you could say it's all plus. Over here all elements till 4 are electropositive in nature. All right, mind you, here I'll just mark it over here, 1 minute. All right, so till here, till silicon, over here, let's take this period's example. Okay, so till silicon, okay, the electropositivity keeps on increasing only till silicon. All right, only till the valency 4, only till the valency 4 the elements are only metals. Okay, or you could say that it keeps on decreasing when, okay, wait, I'm sorry, over here this is a little wrong. It should be like this, and this should keep increasing. Yeah, this is better. I'm sorry, metallic character decreases from left to right. Remember, metallic character decreases from left to right, but non-metallic characters increase from left to right. Now let's go on to the fifth property. I want to explain the rest properties. It's actually easy. The moving from left to right, the chemical reactivity first decreases and then increases. All right, the chemical reactivity first decreases then increases. The variation in chemical reactivity of elements in period can be explained as follows. In the first element of the third period, sodium, there is one valency electron which it can lose easily to react with other substances. So it is very reactive. The second element, magnesium, has two valence electrons. It is not so easy for an atom to lose two electrons. So magnesium is less reactive than sodium. Aluminium and silicon are still more unreactive because they have 3 and 4 valence electrons respectively. Sodium reacts with water vigorously to form sodium hydroxide and hydrogen. Magnesium reacts with water only on heating. Aluminium reacts with water very slowly, and silicon does not react with water at all. Phosphorus has 5 electrons, so it needs 3 more electrons to complete the octet. Sulfur has 6 valence electrons and needs 2 more electrons. Chlorine has 7 electrons and needs 1 more electron to complete the 8 electron structure. Now, it is quite difficult for an atom to gain 3 electrons. It is easier to gain 2 electrons, and it is very easy to gain 1 electron. So, the chemical reactivity increases from phosphorus to sulfur to chlorine. So, as I was saying, first decreases. Now, again, I'm saying like this: till from sodium to aluminium, in any period till the valency 4, the chemical reactivity first decreases, then after 4 the chemical reactivity increases. Now let's move on to the second one, to the nature of oxides. On moving from left to right in a period, the basic nature of oxides decreases and the acidic nature of oxides increases. I'll repeat again. On moving from left to right, alright, left to right in a period, the basic nature of oxides decreases and the acidic nature of oxides increases. We know that when we go from left to right, the metallic character decreases. Metals usually react with oxygen or hydrogen to form bases, but here metallic character keeps on decreasing, the basic nature of oxides decreases. Hence, we get always as nonmetals always react with these oxides and oxygen and all, hydrogen and all, to form acids. Hence, the acidic medium increases. This is the nature of oxides. Hence, we complete the characteristics of periods. Alright, subscribe to my channel and I'll tell you more about the characteristics of groups in the next video. This is just the part 1. Alright, this is your Rocky Bike signing off. Remember, please subscribe to my channel. If you want more videos, please write in the comment section below. Alright, thank you.